Okay, so this is talking about writing compounds, and we're going to start out with Ionic. This is, I don't know, the third or fourth time I've done this. So you're going to see writing already on the notes here. You also see this MOI, I don't know, Malachi came in and got a piece of paper and just started writing on it. It happened to be my notes. So anyway, I'm getting emails from students right now too. So we're going to start out with ionic compounds, and we're going to look at the oxidation numbers. Whenever we wrote the ions, you recall, for example, like Cl, these numbers up here are called the oxidation numbers. So oxidation numbers tell us if it's a positive or negative ion. Remember, if you lose electrons, it becomes positive. It's a cation, and if you gain electrons, it's negative, or it's called an anion from previous notes. There's some oxidation numbers that we're going to focus on. These two in particular, Ag and Zn. If we look on the periodic table, and I forget where I put mine here. If we look in the periodic table, we're not sure about what silver and zinc are. Okay? So, based on my periodic table here, what our notes tell us is this is +1, +2. We skip. Remember how we folded our paper in class? So we couldn't even see the transition metals or transition elements. This is a +3. Nothing, because we don't know, okay? It's 4 valence electrons. So do you gain 4 or lose 4 to get the octet? Get 8. We don't know, so we don't write anything here. 3 minus, 2 minus, 1 minus. So it's like a pyramid. 1 plus, 2 plus, 3 plus, nothing. 3 minus, 2 minus, 1 minus. And then our last ones are already stable because they have a stable configuration. So I'd recommend writing these right on your periodic table. You should have multiple periodic tables by now. 1 plus, 2 plus, 3 plus, skip, or just maybe put a little line above it. 3 minus, 2 minus, 1 minus. And if we find zinc and silver, silver's here. And from our notes, it's a +1. And zinc, where's zinc? Zinc. It's right here. Right there. Number 30. It is a +2 all the time. You see those are in transition metals, but we use them enough where they only have one oxidation number. So that's something that if we were in class, you have to memorize. All right, everything I just said here. Cations, anions, and noble gases, which is our very last column, have no oxidation numbers. Sometimes in our transition metals, they have more than one oxidation number. So you'll see over here, iron 2, iron 3. If you see a Roman numeral 1, 2, 3, or 4, that's the most we're going to have is 4. The Roman numeral tells you the oxidation number, so it's pretty nice. If you ever see this written, you don't even have to think about it. It's always a plus, and you just write a 2, Roman numeral 3, 3 plus. Here's another example down here of copper, copper 1 and copper 2. Okay, now on the back of your periodic table, let me reach over here and get one. You can see mine here. I've already made some notes on it. It's not a bad thing to do if you could read that. On the back of your periodic table, they're called polyatomic ions. And so a polyatomic ion is when you have multiple atoms together of different elements and they still have a charge. So for example, on the back of the periodic table, you can go find carbonate, and it's CO3. But yet it still has a charge. See, we're used to only having zinc or sodium or whatever and having a charge. Now, these actually bond up covalently, and they still have a charge. Okay, and once we do that, we would just combine them with our positive ions as we would anywhere else. Okay, so now let's get into that a little bit. Rules for writing chemical formulas. First off, you always put the positive one on the left side. Okay, now in this one, it's talking about, it mentions the polyatomic ion. It doesn't matter if we're talking about polyatomic ions or any other ions. The positive one always goes on the left. If you notice here, it's really difficult to read. Yours should be better. Or you can look up polys online, Google it, and give you a whole list. Ammonium is this very first one, and it's a 1+. All the other ones are negative. So the only one here that's ever going to go first is ammonium. All right. And then on the right side, that is the negative, okay, ion. So for example, you know, I keep going back to this all the time. Sodium chloride, 1+, 1-. Okay, the positive is always going to go first. My hands are dry from all the hand washing. Okay, binary compounds. We do this crisscross method. So I already wrote, let's go back here real quick. I already wrote sodium chloride here. Now the way we figure out what goes here and here is by crisscrossing. What we're trying to do is get a neutral compound, meaning all the negatives and positives add up to equal 0. Okay. And that's what I'm going to show here. So first off, here's my examples, and I may rewrite them real quick so you can see me do it. I'll leave the first one. Sodium is a 1+, chlorine is a 1-. So you take this one, crisscross, and that's how you get the number of each. We only need one of each. Our second one, I'm going to write it over here. Potassium. I'm showing you how to get the 2 and the 1. Potassium is a 1+. Sulfur is a 2-. See, the nice thing is once we know where those oxidation numbers are and how to do those, right here, we don't need anymore to put all those electron dot diagrams with all the valence electrons. Okay, as long as we know what the ions are and we can use them, that's fine. That was sort of a stepping stone to get here. So I take my 2, I criss, and I cross, and I get K2S1. And we know that we don't need to write the the 1. If the S is by itself, it's implied that it's a single. And then magnesium bromide. All right, magnesium and bromine. Magnesium's a 2+, it's in the second column. Bromine's a 1-, it's in the 17th. And we criss and we cross and we get MgBr2. Okay. So really it's not too bad difficult of a method, okay? The most difficult thing is just getting the elements correct, right? Knowing that sodium's Na, and then also looking up the oxidation number, remembering how the oxidation number relates to the column. All right, down here. This is an example of what I just did. It gives you the steps to do what we did up here. Okay? I'm going to come back to this line here. Like I said, I've done this video multiple times now. How do we get these, right? How do we get these names? So, naming them. The nice thing is, whatever the positive ion is, you always just write it. So for example, sodium, the first one, you just write sodium. And then for the second one, you change the ending to IDE. So a lot of times I still tell students, if it sounds right, you're probably correct. So for example, chlorine, chloride, sulfur, sulfide. Oxygen's weird. Some people put oxygenide, but that just sounds weird. Oxide, fluoride. See all these IDEs on the end? They're replacing the former endings. So you leave the root and you change the ending to IDE. Okay. And that's what kind of showed over here with our 3 examples here. Sodium chloride, potassium sulfide, magnesium bromide. before we get in any more examples, we're going to look at the polyatomics. Okay? So here we have two notes, two examples. Let me cover this up real quick down here. I already mentioned what a polyatomic ion is. So how about a polyatomic compound? It's simply a compound that has a polyatomic ion in it. So first of all, we need to identify what is the polyatomic ion. When you start seeing a bunch besides just two elements, and you start seeing more than that, 3, 4, whatever, there's going to be a polyatomic in there somewhere. So we need to identify what it is. On the back of your periodic table, I'm sure you could find these two groups. Carbonate, I hope, and hydroxide. Okay. So we do it exactly the same way that we did the binary when we only had two just regular compounds, two elements, two regular metal and a non-metal. So first off, Mg is a 2+. We get that from the periodic table. CO3, put it in parentheses, and look up the oxidation number on the back of the periodic table. It is a 2-. So now we're going to crisscross. 2 goes to the Mg, this 2 goes here. 2, 2. And then we reduce. So if there's 2 Mgs and 2 CO3s, we can reduce down to 1 and 1. Sodium hydroxide over here. Sodium is a 1+. OH on the back of the periodic table is a 1-. We crisscross, 1 and 1, NaOH. Now sometimes it's not really proper to do this, but in class if students are struggling with the polyatomics, I allow them to just leave these parentheses on there so they just remember that that's the group. Now how do you name them? I'm getting a bunch of emails now here. Now how do we name them? So you do not change the names really of the elements, okay? So magnesium, the first one still stays the same just like it did before, and then we just write the name of the polyatomic. It's called carbonate. Did I mess up? I said carbonate before. No, I think I said carbonate. Yep, carbonate. So we don't change it to like carbonate-ide or anything like that. Now over here, sodium, hydroxide. Wait a second, what about this IDE? Well, if we look on the periodic table, hydroxide, it's right here. And you notice that is actually the name of it, OH hydroxide. So polyatomic ions are fairly easy most of the time to name them because it's just the regular names of each. The only time we might have something a little bit different is if we have that NH4, which is our positive. Okay. So if we look on our back of our periodic table and we get that one positive polyatomic ion called ammonium, it's a 1+. And let's say it were to bond with chlorine. Okay. So how would you name that? Well, the polyatomic just stays the same. And what do we do about the last one? I keep looking at emails that are being sent. Sorry about that. So now we don't do chlorine. Remember before when it was just a single element by itself, a non-polyatomic, we had to change the ending to IDE. All right. So if the last one is a polyatomic, just write the name. If the last one is a single element, then we need to still change it to IDE, ammonium chloride. Okay. And here we go. There's the notes of what I just said. And here I'm mentioning, if you could read that. There's my ammonium, and we still have to change the other ending to IDE. Oh, examples, here we go. Next video.